Okay, are you here because you want to learn a PLC programming? Okay, I will give you 5 seconds to change your mind because this is so easy. Oh, you're still watching, meaning you are interested and you are watching on the right channel. Okay, in this video, I will show you how to create a ladder programming using OMRON PLC software, the CX programmer. With the function of Work Online Simulator, we can test run the program without PLC hardware. Okay, let's start to our main topic. So, the basic sequence level 1. So, we have a level list of sequence that you can learn. Basic switch, inverter, etc. etc. If you master the basic sequence level 1, you can create a simple project or a complex condition in your project. Okay? So before that, have to familiar you have to familiarize the OMRON PLC address list, starting of the configuration of input output. It's a CIO 0 up to CIO 6140. This is the external address use of inputs and outputs. Then the working bit, it's the internal address W0 up to W511. Holding bits, internal address also H0 to H511. So what is the difference of these two? So for the work bits, can be used to simplify the programming when a certain combination of a condition is repeatedly used in a combination with other condition. So it will help to reduce the complex condition. Okay, so we can use this address during simulation or our practicing. Holding area bits is data and holding area bit is not cleared when the power cycle. So if you encounter the power interruption, so the data store is not cleared or not cleared. Okay, and next is the timer numbers. We have a 4090 T0 up to T1000 40,090. So next to timers, we have T0 up to T4090. And then zeros also is C24090. We start to the T, the timers. Start to the C, the counters. And the D is the data memory up to 32,760. Data memory stored values is the data word memory. You can store some data of your and data memory 0, 32,000, and the data memory D0 up to 32,760. So we can store the values memory. Okay. Next, PLC address format. So and the first is what you call channel. Dot. The next one is bits. So channel dot bits. So the one channel is equal to 16 bits maximum. Example, we have a channel CI 100. So we can use the address up to, so example, the channel CI 100, you can use the 16 bits addresses. So start of 100 bit 00 up to 100 bit 15. Okay. So OMRON PLC has a built-in inputs outputs. So the channel is written and the PLC hardware. So example, this one is a 0 channel with 12 bits only, and the one channel is 6 bits only. So we can use the 0 bit 00 up to 0.11. and the CIO 1 bit 00 up to 1 bit 05. And the output is start to 100 child. So 100 with 8 bits, CIO of 100 bit 00 up to 100 bit 07. And 101 child bits with 4 bits, CIO 101 bit 00 up to 101 bit 03. So this entity series meaning you have 12 plus 6 is 18 bits, 18 inputs, and 12 outputs. So 18 plus 12 is 30 and 30 series. Okay? And take note of this. Okay? So let's start with the number one, the basic switch. Basic switch is just inputs and outputs. The reaction of inputs is also the reaction of the outputs. Okay, open the CX programmer. This is the icon. Just click CX programmer. Okay, let's create a new project file. So just click this white icon or new file. Then device name. So let's say this is basic. No spacing underscore level underscore 1. No spacing for the device name, then device type. So we have example of CP1 E series. Settings for the CPU type is select N30. Then OK. Network type is just USB. So regardless, because we use work online simulator to run this program. OK. Then zoom out. Okay, so this is what you call a rung. So a rung is a single line of ladder program which contains a complete single set of logic instructions which allow power to flow from the left bar to the right bar. So if you're familiar to the electrical diagram, you can read that. So this sample of the left bus bar and the right bus bar, or your power source is AC. So this is your line 1, this is line 2. Okay? So if you want to insert more rung, so click this rung or right click, then rung, then insert below, or you can insert above, rung, insert above. So you can insert more rung. Okay? So let's delete this one. So for the basic level 1 topic first is the basic switch. What is the basic switch? So normally the basic switch is if the input is turned on, the output is turned on. If the input is turned off, so the output is turned off. So directly proportional. So this is what you call a cell. Separated cell. Okay. Let's create a ladder program for the basic switch. So before that, double click this rung. So we can rename it for the rung comment. Rung properties. Just name it, let's say number 1. Basic switch. Then enter. Or close. So this rung, we put the basic switch. Then highlight this first. Input the normally open. Type C. So example for the address is 0 bit 00. Then enter. Then edit comment. Let's say this is push button 1 or PB1. Okay. Then you need to insert the line. Okay. This line, the shortcut key is just hold the control, then arrow key. So you can forward. If you turn back, it will raise down or up. Okay. Let's insert to the line to the right bus bar. Then inserting the coil for the output, just type O. let's say our address is 100 bit 00. Enter. Name it. Let's say this is output 1. Okay, let's try this basic switch using simulation. Simulation, work online, simulator. Okay, so we are running to the work online simulator. So we will trigger this bit 0, this input. So highlight, then press control, hold the control, then J. Then control hold the key to turn off. Control J, K, J, K, K. Control the J. You can see this control force on. Okay, highlight this. Control J for the force on. Control K for the force off. Control L to remove the lock. J, K, L. So if you push button is turn on, the output is turn on. If push button is turn off, the output is turn off. So that's a basic switch. So remove the unlock, just control L. Okay? Okay. Next. So turn off the simulator. Next, number 2 is the inverter or NOT. What is the NOT? So this instruction, NOT or NOT, if you're familiar to the logic gates, NOT, this is the reverse the execution condition. In other words, if the input is turned on, the output is turned off. Okay? Vice versa. If the input is turned off, the output is turned on. Okay? So let's create the inverter or NOT. So we insert to the next rung, okay? Rung 1. So let's double click to put the rung comment. Number 2, inverter or not. Okay, so the condition is if the input is turned on, the output is turned off. Let's put an example of ladder. So first cell, type C, contact, for the normally open. Example 0 bit 01, then PB2 for the comment. Then put the line, control arrow, then coil output, then 100 bit 0, 1 for the output, 2. So the NOT instruction is inserting to the between execution, in between. So we put into in between of the input and the output. So the second cell example, just type I, insert new instruction, just type NOT, enter. Okay, so let's try simulation, work online simulator. So for the basic switch, if the basic switch is turned on, input, the output is turned on. As you can see, the inverter, the input is off, but the output is on. If I turn on this switch push button, the output is turned up.
So let's
create a simple inverter. We have 3 types of inverter with a ladder sequence. Okay, let's try. Turn up first the simulator. Okay, toward the next rung, insert the contact C 0 bit 02, then let's rename it PB3. then control line, hold line, just type O 100 bit 02 and enter. Name it for the output 3. So to invert this output, just highlight this output, this coil, just type X. So you can normally close the coil, or you can normally close the input. So let's insert this contact. Let's say this PB4. You can normally close this. So the coil is 100 bit 03. So insert the normal coil. So let's check. So as you can see, this 3 is the same logic, or the invert the output. Control J, Control J, C, turn up. If the switch is on, the output is turn up. Okay. Control K, turn up. Control K, turn up. Control K, turn up. Okay, that is the basic switch and the inverter. You can select what you need this type of inverter. Okay, let's go to the next topic. So the third topic is latching circuit or self-holding circuit. So latching is used for the circuit that is able to hold the output energized even though the input which energizes it ceases. It is used to set the output permanently with a momentary usage. For example, if we press the switch or this momentary switch 1 to turn on the output, and that output is used to latch, the circuit is to run it continually until the switch 2 is pressed. Okay, let's try this circuit using CX Programmer. So let's create this first run. So for the first cell, type C, then input address 0 bit 00. Let's rename it, enter, switch 1. Okay, then normally close input switch 2, normal close, type X, then 0 bit 01 for the input address, then switch 2, or name it switch 2. Then the coil for the output. Okay, let's rename it, type O, 100 bit 00, enter, output for the comment, output 1, and then parallel the output contact to the 0 bit 00. So rename it 100 bit 00 for the output. So this is a complete latching circuit. Okay, so let's try this. Simulation, work online simulator. Okay, close. So imagine this 2 switch is momentary type switch. Okay, so let's start to trigger this 0 bit 00. So switch 1 press, then release to turn on. The output is turned on. So it's retain itself. And then when I press the 0 bit 01, then it's turned off. So press, release, press, release. So that is the latching circuit. So I will show you the latching circuit using the instruction type of this CX programmer. Okay, so I will put these to the next round. Try to use the keep instruction. So keep is also operate as latching relay. So this is the instruction of keep. So we have two inputs for the set and reset. So when input set is turned on, the designated bit will go on and stay on until reset, regardless of whether input stay on or goes up. So when input reset turns on, the designated bit will go up. Okay, so let's try using CX programmer. So the first cell, just type C, let's say 0 bit 02 for the set input. Let's name it set input. Enter. Then arrow, just type I instruction, then just type keep space the bit you want to use to turn on or the output 100 bit 01 output 2. And as you can see, the next line for this keep is for reset input. Okay, so below the set input, just type C 0 bit 03 reset input, then connect with line. Okay, let's try simulation, work online simulator. So when I turn on the set input, so the output bit of 100 bit 01 stay on, regardless when I turn on this, turn on, okay. So when input resets turn on, the output bit 2 is turn up. So it's operate as also the latching relay. So its logic is the same. Okay, so let's try another latching with the next instruction is the set and RSet. So set and RSet is also a latching circuit. Sample those sets turn on the operation bit when the execution condition is on. So at inputs, we have also bit. Regardless, so it remains goes on regardless of on-off input condition. Okay. So for the RSet, turn on the operate bit when the execution condition is on. So after this specified contact will remain off regardless of on-off input condition. Okay. So if you turn on the input for the RSet, the bit will turn up. Okay. So let's try to the CX programmer. Okay. Just next round. For the next round, type C 0 bit 04. Say this is set input A sample. L9 connect to line. Just type I. Then press C. Just type set SAT space the bit you want to turn on 100 bit 02. Say this is output 3. Okay, so for the RSet instruction you have to input to the next rung. Okay, so type C 0 bit 05 RSet input A. Connect to the line, then I type I Type rset, rset, just rset, no reset. Space, the bit you want to turn off. So it's a 100 bit 02. Output 3. Okay. So let's try again. Work online simulator. So for the set instruction, when I turn on the set input A, so the 100 bit 02 is turned on. Whether the input stay on or goes off, it's also latching. Okay. So when the input reset is off, the designated bit for the rset is goes off. Okay. So as you can see, the set and reset inputs for a keep instruction must be programmed with instruction. But the set and rset can be programmed completely independently. So you can separate these independently because this has two instructions. It's only one, but two inputs. Instruction must be programmed. Okay, so that's the latching circuit with the coil, with the instruction, keep and set and rset. Okay. Okay, let's go to the next topic. So the next topic is timers. So we have two types of basic timers, that the on delay timer and off delay timer. Okay, so let's go to the on delay timer. So on delay timer is when the input is turned on, there's a delay before the output is turned on. So for this example, we use the TIM instruction. So we have inputs and the TIM instruction. So TIM is operates a decrementing timer. So this is a 100 ms timer. So it is a BCD type. And then for the next column for the TIM is the timer number. So we range this, the T0 to T4090. So we have a 4090 timers inside the PLC. Okay, and the next is the set value with a range of 0 to 999. So you need to put the hashtag if this type of instruction is BCD type. Okay, so if you read this value or set value is 5 seconds. So because this timer is 100 ms timer, so 5 or 50 times 100 ms is equal to 5000 ms. It's equivalent to 5 seconds. Okay, for the on delay timer, so we also have for the TIM, we also have a timer completion flag. Depends to the timer number that we use. Okay, so let's check to this timing chart for the on delay timer. So you can see, so if the input is off, so all is off. If you turn on the inputs, the time BB will begin counting down from the set value. It's a decrementing, so it's counting down from the set value, and the timer completion flag T0 will be turned on when the PB reaches the 0. Okay, so when the input goes off, the timer will be reset to the set value, and the completion flag will be turned off. So let's try to input this with the CX programmer. Okay, so let's rename this rung. Double click. Let's say this is number 4. Yeah, that's a number 4. The on delay timer. Close. Okay, so we need the input for the switch. Let's say this is contact type C 0 bit 00. Say this push button 1, and then the line, then to point the line, control arrow. Then timers is instruction type, so type I, just type TIM, so TIM space the timer number space the set value. So that's what you type. So space timer number, example CSC 0. So you don't need to type T0. It's automatic because this is inside the timer. Only numbers. Then space hashtag, put a hashtag or number sign. For example, is 50 for 5 seconds. Then so hashtag 50, then okay, enter. Edit comment, let's say this is timer 1. Okay, then we need to input the timer 0 completion flag. So to the next rung, you need to input to the next rung. Okay, contact type C, just type T0, enter. So automatic that it's a comment. You already input the comment for the timer 0, enter, and then the output you want to delay or to turn on. Okay, put the line, then type O, let's say this 100 bit 00, then the output. Okay, so let's try this. Work online simulator. So when the input goes from off to on, let's try this, the push button. When the push button goes from off to on, type just Ctrl J or force on, Ctrl J. So the timers begin the countdown from the set value, and the timer completion flag is turned on, and the output will be turned on. Okay, as you can see, the reaches the 0, the timer 0 is on. So we also turn on the output. So when the input goes up, the timer PB reset to the set value, and the completion flag will be turned off. So as you can see, this TIM works only if we use the alternate switch type. So what happens if we use the momentary type switch? So the 0 bit 00 turn on, press, then release. So the TIM or the timer is not working if we use the momentary type switch. So the solution of this problem is we need to add the latching circuit. So let's try to edit this ladder program. We have to add the ladder or the latching circuit. Okay, so I need to edit to insert the rung above. So I just highlight this rung 0. So right click, rung, insert above. So we have to create a latching. So type C, input the contact, normally open. Let's say 0 bit 00. Use a push button 1, we use the push button 1, then normally close, type X, a 0 bit 0 to 1, enter, push button 2, then line, then output for the latch. Now we will use the internal relay, the W, or work bits 0W 0 bit 0 0, then latch, that W 0 bit 0 0. So we use now the latching. The W bit 0 0 address is internal only for the meet the condition that we need. Okay, so we have to replace this input using the latch output, the W bit 0 0. We need to edit this, replace to W bit 0 0, enter, then latch. So here's the full ladder diagram of on-delay timer using momentary switch. Okay, so this is set button and this is a reset button. Try simulation, work online simulator. Okay. Let's try this. So let's press this push button, set, press and release. So you have created the latch, then your timer is now working. So you need to release this latch using the push button 2 to turn off the output. Control J, K out. Push button 1, release, and then press release. So that is the on-delay timer. Okay, let's move to the off-delay timer. Next topic is off-delay timer. So off-delay timer, when the input is turned on, there's a delay before the output is turned off. So it's opposite to the on-delay timer. So we will use again the TIM instruction or the 100 ms timer. As you can see the previous topic, the TIM operates already as on-delay timer. Okay, so we will use again this using the off-delay timer sequence. So for the timing chart, so the timer input so it goes from off to on, the timer PB will begin counting down and the output is turned on at the same time. So when the timer completion flag will be turned on after the timer PB will reach the 0, so the output is turned off. So when the timer input goes off, the timer will begin reset to the set value and the completion flag will be turned off. Okay, so let's try to write to the CX programmer. Okay, so rename this run. So we have a fifth topic, the off-delay timer. Okay, so we have to create a latching first. Okay, so type C, say 0 bit 0 0, say it's a push button 1. So example, we will use again the momentary type switch. Okay, so type X for normally close, push button 2, then we will use the call as CIO address. Okay, no need the work bit. So we can straightly directly CIO 100 bit 00 output one example. Then create the latching 100 bit 00, then arrow. Okay, so the timer can also create this kind of shorting the round. Okay, we can input this to the line of this timer, just type I, then timer 0 example, then let's say 5 seconds for the off delay, then enter, say this timer 0. So we need to reset this output automatically when the timer completion plug is turned on, the output is turned on or turned off. So we have to insert here as reset. So T0 normally close. Okay. Okay. So let's try this. Work online simulator. Okay. So when I press the 0 bit 00, press release. So the timer is running, countdown, and the T0 is on. It will cut the line of latching, so it will be turned off. So output is on, and there's a delay before the output is turned off. So when you press the 0 bit 00 and then you interrupt the 0 bit 01, it will interrupt manually turn off. This is manually turn on, manually turn off, manually turn on. This is your automatic turn off for the off delay timer. Okay, that is the off delay timer. So next, how about the on off delay timer? So on off delay timer is the combination of on delay and off delay timer. Okay, it's a simple. So let's write directly to the CX programmer. Okay, so we'll rename this, double click, run comment. This is number 6. On off delay timer. Okay, so first we have to create a latching. So type C, set 0 bit 00, set this PB1 start. Let's rename this start. Then normally close 0 bit 01, PB2 reset. Then for the latch, we need to use the internal relay, the latching. So because we have example, we have only a 2 push button and 1 output. Okay, so WB00 latching. So we have to create first the on delay timer. So let's parallel the timer and this latch. Type I, TIM, same for this 0. Let's say 5 seconds. For the on delay, let's say this timer 0 is on timer. Let's name it on timer. And then go to the next rung for the completion plug of the timer 0. Timer contact T0 on timer. Then to the output, just type O for the coil, 100 bit 00. This is the output. Okay, and then this program is on delay timer, and we will automatically off the output. So first is on delay, the next is off delay automatically. So we can parallel the timer here. So just type TIM. So our next number timer is 1. So for the timer, no duplication of timer number. Okay, no duplication. Then let's say this is 3 seconds for off timer. Okay, for the completion flag, so of the off timer, to turn off this, we can insert here or down to the main latch. Okay, timer 1, we can insert to the interlock here, the reset off, using timer 1 for the off timer. Okay, so as you can see, we have a long instruction. We can change the appearance of this instruction to prevent this scrolling. Okay, so just tap tools option, then check the show output instruction horizontally, so we can see the whole program easily. Okay, now it's in horizontal. Okay, so let's try this on off delay sequence. Okay, downloads, close. So okay, when I press the 0-bit 00 of the push button start, press release. So the on timer running is delay the output on delay, and then automatically output is off. On delay, and then off delay. Reset the main latch. Okay, so when the W0B00 is off, the timer 0 is off. Timer 0 is off. The timer 1 is also off. So the output is off. Press release. On delay, and then timer running for the off timer, off delay. So that is the on off delay timer. Okay, so let's go to the number 7. We can move to counters.